So this is 2014 June, Decision 1, Question 2. We're going to have a look at this. So it's a document translated into 6 other European languages. There's a table that I'll show you in a minute that has Danish, English, French, German, Hungarian, Italian and Spanish. So on the bottom, it's once the order, we select the edges using Prim's algorithm. So here's the table. I'll pull it over just a little bit. Okay, and it wants us to show in order what we're choosing. So I think we have to start from E. So we're going to start from E. So we label one E and delete E. Okay, so from E, I look down this column to find the shortest one, which is 70. Okay, so I'm going to write down here, which you don't need to, but it's always good to. So E goes to F. F gets labelled 2, delete F. We're now looking down both this column and this column to find the shortest. So I've got 80, and I reckon 80 is the shortest. So E to G is the next one I will choose. So G is 3, delete G. I'm now looking down the French, English, French and German columns to find the shortest route. There's an 80 up there. And I think that's the one I'm going to go for. Yep, so I'm going to choose that one. So my next one is G to D. Okay, so then D gets labelled 4. Delete D. Okay, so now I need to look down all 4 columns, which just gives us this to look down, which I think 85 is the shortest. So my next one was F to I. Okay, I gets labelled 5. Delete I. Okay, so now I've got Italy, which has got a 60 over here, which looks like it might be the shortest. So I'm going to circle 60, which is Spanish. Then I goes to S. S gets labelled 6. Delete 6. Look down all the routes. I've only got this line left. And the shortest one is 110. So the last one would be G to H. And that becomes 7, and then we delete this. And that's Prim's. Okay, so we would add those up. So I need to find a calculator and add those up. So we've got 70, 80, 85, 110, 80 and 60. And that gives us 485 is the total of Prim's algorithm for that. So if we look back at the question, on the table below, use Prim's algorithm to form a minimum spanning tree connected. That's what we did. The length of the spanning tree is 485. Draw your minimum spanning tree. So, oh, wrong way. So we've got, I'll try and draw it over here. So we've got E to F. A, B, C, D, E, F, G, E to G, G to D, F to I to S, and G to H. Okay, it doesn't really matter how it works out. In fact, it turns out you could have H, G, D, and then everything coming off there, but that's fine. It doesn't really matter as long as you do it. On a particular day, Jenny travels from, wrong one, go back to the question. It is given that the graph has a unique minimum spanning tree. State the 2 edges that would be able to complete the minimum spanning tree in the case where Prim's started from H, or cruscals. So Prim starting from H, you would start here. And so Prim's means that you would add on 2H all the way. So the last 2 that you would have is F to I and I to S to make this, because G to D would have come in sooner, because I to S is 60, so that's 60. I to F, or F to I, is 85. G to D is 80. So that would have come before 85. So the last 2 there is FI and IS. And if you're using Kruskel, the two biggest ones would be the last ones in, regardless where you're doing it. So it'd be definitely be this one, and the one before that would be that one. So it would be I to F again, and G to H would be the last two for that one. And that's that question done.